Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 712. Minimum ASCII delete sum of two strings. Problem statement states, given two strings S1 and S2, return lowest ASCII sum of deleted characters to make two strings equal. Okay, the idea is to make two strings equal. Okay, the problem statement says we have to make two strings equal. Okay, so in order to make two strings equal, we are supposed to delete few characters from it if both the strings are not equal. Okay, so whatever characters we are deleting, we have to get the ASCII sum value of those characters and return it. Okay, so whenever we are deleting characters, we have to choose the characters in such a way that the sum of the deleted characters, sum of ASCII value of the deleted characters should be minimum. Okay, so how can we solve it? Okay, so let's take S1 is SEAS and S2 is EAT. Okay, so at any given point, at any given position, okay, I have certain options to take. Okay, the first option is if both the characters are equal, okay, then I don't have to do anything. Then I should simply get the minimum answer from the rest of the string. Okay, but here if you see the first two characters are not equal. Okay, if both the characters are not equal, either I choose to delete this value and get the minimum answer from this string and the remaining entire string, or I choose to delete the first character from the second string and get the minimum answer for this entire string and this remaining string. Okay, so here if I choose to delete the first character from the first string, then the answer would be ASCII value of S plus minimum sum of the remaining characters of the first string and the second string itself. And the next possible option is the deleting the first character from the second string. Okay, so this is the second option I have. Okay, so the final answer of my S1 and S2 would be the minimum of these two, because we want the ASCII value sum of the minimum of these two answers. Okay, so again, in order to get answer for this, again I have, if you see this, these two characters are same, so I don't have to do anything. I will simply get the answer for the remaining strings. Again, A and A is also equal. Again, I don't have to do anything. I should simply check what is the minimum answer I would get from S and T. Okay, so again here I have two possibilities, either I choose to delete this or I choose to delete this. Okay, so if I choose to delete this, then the ASCII of S plus minimum of the empty string comma T, and then if I choose to delete the first character of the second string, then this would be the answer. Okay, in the end I have to take the minimum of these two. Now at any given point of time, I would reach a state where one of the strings would reach to empty and other string is non-empty. Okay, if I reach such state, that means that I have to delete all the characters from the non-empty string. Then only I can make two strings equal. Okay, if one string is empty and other string is non-empty, the only possible solution is to delete all the characters from the second string and make it empty, and then both the strings will be equal. Okay, so whenever I reach this position, all I have to do is to get the summation of all the ASCII values of the non-empty string, and that would be my answer. Okay, so I hope you understood the decisions which we are making in the given tree. Okay, at any given point of time, if both the characters are equal, then I have to get the answer for the remaining string. Okay, if both the characters are not equal, then I have two possible options. Okay, either I choose to delete the first character from the first string, or I choose to delete the first character from the second string. Okay, so what I will have to take the minimum of these two answers. Okay, so as you can see, we are basically choosing options at any given point. Okay, so there will be, if you draw this entire decision tree, you will see that there are certain function calls which are actually repeating. Okay, so the idea is to memorize the answers which you have already calculated before, so that you don't have to recalculate it again and again. Okay, so I will show you the recursive solution which I have implemented. Okay, let's say I have a function called minimum sum which will tell me the minimum sum which I would get by deleting certain characters to make two strings equal. Okay, so I is the index which is pointing to the first string and j is an index which is pointing to the second string. Okay, so as I mentioned, if both the characters are equal, then my answer would be just answer for the next substring. Okay, so I would just increment my I pointer and j pointer, and whatever answer would I would get, that would be answer to my current function call. Okay, if both the characters are not equal, then either I have to delete the first character from the first string, or I have to delete the first character from the second string. If I choose to delete the first character from the first string, then I have to get the answer from I plus 1 till j, I plus 1 comma j, and I have to get if I choose to delete the j first character from the second string, then I have to get the answer from I comma I plus 1. Okay, so in the end I have to take minimum of both the answers, and that would be my final answer. Okay, since it is a repetitive solution, and since there are certain function calls which are repeating, I have to memorize. Okay, so before jumping into memorization, let me just tell you the base cases. Okay, as I mentioned, okay, once we reach the end of the string, and if both the indexes reaches the end of the string, that means I have reached a state where, let's say, both the strings are eat and eat. Okay, s1 is eat and s2 is also eat. Okay, so my both I and j pointers will increment simultaneously, and I would reach the end of the both the strings. At this, for given this particular state, that means if both the strings reach the end of the end, then I don't have to delete any of the characters. I can simply return 0. Okay, if I've reached a situation where one of the index has reached the end, whereas other has not reached the end, that means that I have to include the characters of the string which does not reach the end. Okay, so I'm just defined a variable called sum equal to 0, and I'm iterating through the string which has not reached the end. Okay, and I'm just adding the ASCII values to my answer, and similar way I'm just looping through both the strings and then adding the ASCII values. Any one of these loops will ideally get executed, and the ASCII values will get added to the sum, and then we are returning the sum. Okay, and as I mentioned, the function calls are, there might be some repetitive function calls which we don't have to compute again and again. So we have just instantiated a cache which is of length plus 1 of first string and length plus 1 of the second string, and then ideally till length would also be sufficient. Okay, so and then we have populated the entire cache with -1, so that none of the possible states has been calculated before. Okay, the moment we calculate the state, okay, if the state was already calculated, then we will return the calculated state. If the state is not calculated, then at the end we will be populating the state with the answer. Okay, so let's try to execute this problem. As you can see, base test cases were passed. Let's try to submit this. As you can see, all the test cases were also passed, and it is pretty efficient solution. Okay, so before jumping dive into analyzing the time complexity and space complexity of this algorithm, I highly recommend you to subscribe to my channel. Okay, so I will be posting the daily Leetcode videos. Okay, so let's try to analyze this problem. Okay, as you can see, j is starting at 0 and going all the way up to the length, and I is going starting at 0 and going all the way up to the length of the first string, and j is also starting at the first index and going all the way up to the length of the second string. Okay, and all possible, what are the possible states which are what is the total possible states which are possible, which is I times j. Okay, so the length of the first string times the length of the second string. So we are actually using an extra space of order of m into n, where m is the length of the first string and n is the length of the second string. And so we are only computing these states. Okay, so the time complexity would be order of m into n, and space complexity is also order of m into n. Okay, so yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. Thank you.